today we're going to review what we've talked about this whole week. So we're going to review absolute value. Remember, absolute value represents a positive. So if you have the absolute value of -6, it's going to simplify into a +6. When you have absolute value equations and it equals a number, you're going to make two equations. One equaling the positive number, one equaling the negative number, if that number is positive to begin with. Now, if your absolute value equation equals a negative number, it's going to be no solution. If you have absolute value equations with variables on both sides of your equal sign, then you're still going to make two equations, one where the expression is positive, one where the expression is negative, and you're going to solve both of them. And after you have your two solutions, you need to plug them back in to the original problem and verify if you have a true statement or a false statement. When you have variables on both sides, it is possible to have two answers, or it's possible to just have one solution if one of your solutions turns out to be false and one of your solutions turns out to be true, or it's possible to have no solution if both of them are false. So now let's talk about absolute value inequalities. In an absolute value inequality, you also have to isolate the absolute value. If you have a less than statement, you have an and statement. If you have a greater than statement, you have an or statement. If you have an and statement on your number line, you would shade the middle portion. In an or statement, you would shade the outside portion. If your absolute value inequality has an inequality to a negative number, then your answer is either going to be all real numbers or no solution. If your absolute value is less than a negative number, well, that would be no solution. If your absolute value is greater than a negative number, that would be all real numbers. So, those are all the topics we've covered this week. So what we're going to do now is we're going to look at 3 examples that review everything we've done this week. So here we have example 1. Example 1 is 4 times the absolute value of 3x minus 1 plus 20 equals 8. So I'm going to subtract 20 from both sides to solve. That eliminates the 20. And we get 4 times the absolute value of 3x minus 1 equals a negative 12. I divide by 4, reducing the 4, and I get the absolute value of 3x minus 1 equals negative 3. My absolute value should be a positive number, but this says it equals a negative number. This is not possible, so we cannot continue solving at this point. So, at this point we would say we have no solution. If it had been positive 3, if we had positive 3, let's just say, for example, we had the absolute value of 3x minus 1 equals positive 3, then we would make 2 equations. We would say 3x minus 1 equals positive 3, or 3x minus 1 equals negative 3. We would write that, and then we would solve both equations, and we would get 2 solutions. Okay, so here's our second review problem. We have 2 times the absolute value of 4x minus 12 minus 6x equals 4x minus 12. Our absolute value is not isolated, so we need to isolate it. We're going to add 6x to both sides here, eliminating the 6x. And we get 2 times the absolute value of 4x minus 12 equals 10x minus 12. So now we're going to divide by 2. Now when I divide by 2, I divide that 2 by both of these numbers here. We divided by every piece of the other side. So this is going to reduce, and we get the absolute value of 4x minus 12 equals 5x minus 6. And now we need to write 2 equations. We're going to say 4x minus 12, sorry, I wrote a 4, I meant 12. 4x minus 12 equals 5x minus 6, or 4x minus 12 equals a negative 5x plus 6. We change both of the signs. So now to solve, on the first one, we're going to add 12 to both sides, eliminating the 12. We get 4x equals 5x plus 6. We're going to subtract 5x from both sides, and that gives us a negative x equals a positive 6. Dividing by negative 1 gives us x is equal to negative 6. So now we work on the other equation. We're going to add 12 to both sides. So we get 4x equals negative 5x plus 18. Now we're going to add 5x to both sides here, eliminating the 5x, and we get 9x equals 18. We're going to divide by 9, reducing the 9, and we get x equals 2. So now we need to check both of these solutions. So I need to plug negative 6 into the original problem. So we're going to say 2, let me give a little bit of space here, 2 times the absolute value of 4 times negative 6 minus 12, oops, that should be absolute value, minus 6 times negative 6 equals 4 times negative 6 minus 12. So now, over here on the inside, 4 times negative 6 is negative 24. So we're going to say 2, absolute value of negative 24, minus 12, minus 6 times negative 6. That's 2 negatives, so that's going to be a positive 36. Equals 4 times negative 6, that's negative 24, minus 12. 2 times the absolute value of negative 24 minus 12 is a negative 36. Plus 36 equals negative 36. This is 2 times the absolute value of negative 36. The absolute value of negative 36 is just 36. So we're just going to write it in parentheses as 36. Plus 36 equals negative 36. 2 times 36 is going to be 72. Plus 36 equals negative 36. 72 plus 36 is 108, which equals negative 36. 108 does not equal negative 36. This is false. So what that means is that x equals negative 6 is extraneous. X equals negative 6 is extraneous. So this is not a solution. So now let's check our other solution. X equals positive 2. So we're going to say 2 times the absolute value of 4 times 2 minus 12, close the absolute value, minus 6 times 2 equals 4 times 2 minus 12. So this is 2 times the absolute value of 4 times 2 is 8, minus 12, close the absolute value, minus 6 times 2 is 12, equals 4 times 2 is 8, minus 12. So now at the beginning, we're 2 times the absolute value of 8 minus 12 is a negative 4. Close the absolute value. Minus 12 equals 8 minus 12. 2 times the absolute value of negative 4 minus 12. The absolute value of negative 4 is just 4. So this is 2 times 4 minus 12 equals 8 minus 12 is a negative 4. So now back at the beginning, 2 times 8 is 8. Minus 12 equals negative 4. 8 minus 12 is negative 4, which equals negative 4, which is true. So, since we get a true statement, when we plug in 2, x equals 2 is a solution. And for this problem, we have one solution. If both of these had turned out to be true, we would have had two solutions. If both had been false, we would have had no solution. So here's our third example. We have an inequality. We have -4 times the absolute value of 3x minus 7 plus 10 is less than or equal to 30. So we need to isolate the absolute value. So we're going to subtract 10 from both sides, eliminating the 10. We get -4 times the absolute value of 3x minus 7 is less than or equal to 20. We're going to divide by -4 on both sides, reducing the -4. We get the absolute value of 3x minus 7 is greater than or equal to, because we divided by a negative. Remember, when you divide by a negative, you flip the inequality. And this is going to be a -5. So now, we have the absolute value of 3x minus 7, which is a positive number, is greater than or equal to -5. Well, a positive number is greater than a negative number. This is always true. This is just true. So we don't have to worry about an and statement or an or statement. We simply have a number line that is true everywhere. We shade the whole thing. So our interval notation would be -infinity to infinity. If this had been less than or equal to, or if it was just less than, it would have been false, and we would have had no solution. No solution looks like this, okay? If we would have had a +5, let's say we had a +5. If we had the absolute value of 3x minus 7 is greater than or equal to 5, then we would have had an or statement. We would have said 3x minus 7 is greater than or equal to 5, or 3x minus 7 is less than or equal to -5. And then we would solve both of these inequalities, and we would graph the necessary portions on a number line, and then we would write our proper interval notation, which you can look at those notes in previous videos, and you can also look at previous examples that are in Schoology. I hope you enjoyed today's review on absolute value. If you have any questions regarding any part of this week's lesson, please feel free to send me a message in Schoology, or you can send me a text. Remember, you have a quiz and a review this week. Have a great weekend.